Hello, in this lecture we'll find out the area of quadrilateral AC or D. In the drawing we have a quarter circle. A or B is a quarter circle. You know that side AC equals to 24 units, side CD equals to 7 units. This angle ACD equals to 90 degrees. And our mission is to find out the area of this quadrilateral AODC. So, first of all, we know that AOB is a quarter circle, therefore this angle equals to 90 degrees. And point O is the center of the circle that we can create by completing the quarter circle to a circle. So this angle equals to 90 degrees. Yeah, point O is the center of the circle that we can create by completing the quarter circle to a circle. From point O, that is the center of the circle that we can create by completing the quarter circle to a circle, we will draw perpendicular on chord AC. Actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC is P. We do another now actually we know that from the center of the circle that we can create from the quarter circle by completing the quarter circle to a circle, that is to say from point O, we draw perpendicular on chord AC, and here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of this circle. AB is chord inside this circle. From point O, that is the center of this circle, we draw perpendicular OM on AB. OM is perpendicular to chord AB. And whenever you draw a perpendicular from the center of the circle towards any chord, it will bisect the chord. So if OM is perpendicular to AB, then AM will be equal to MB. Okay, AM will be equal to MB. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing, from the center of the circle that we can create from this quarter circle, that is to say from point O, we draw perpendicular on chord AC. Therefore, according to rule number 11, the perpendicular OP bisect chord AC. That is to say AP equals to PC. Okay, so if AP is total, AP equals to PC, AC in total is 24 units. So OP bisects chord AC. That is to say, each half will be equal to 24 over 2, ASP will be equal to 24 over 2, and PC will be also equal to 24 over 2. So AP is 24 over 2, that is 12. PC is also the other half, that is also 12 units. So actually here we implemented rule number 11 in our drawing. According to rule number 11, the perpendicular OP on chord AC also bisect chord AC. That is to say, OP divides chord AC into two halves. The first half is 12 and the second half is also 12. Okay, so in the next step, we'll do another construction from point D. We'll draw perpendicular on OP. Okay, from point D, we'll draw perpendicular on OP. So actually, this angle equals to 90 degrees. And this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and OP is Q. So inside quadrilateral QPCD, we have 1, 2 right angles. The sum of right angles is 90 times 3 is 270 degrees. Plus the size of this fourth angle. In total, the sum of those four angles must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees, therefore the missing angle here must be equal to 90 degrees. So we found out that quadrilateral PCDQ has four right angles, therefore quadrilateral QPCD must be at least a rectangle if not a square. So actually it cannot be a square because side DC is not equal to side PC. PC is 12 and DC is 7. So we relate to quadrilateral QPCD as a rectangle, and you know that the opposite sides of a rectangle are equal to each other. That is to say PC equals to QD, but PC is 12, therefore QD must be also equal to 12. Likewise, in rectangle QPCD, side CD must be equal to side PQ. But CD is 7, therefore PQ must be also equal to 7 units in its length. Okay. So here we define the length of QO of this line segment QO is X. We define angle ODQ, this angle is alpha. We'll focus on the right triangle ODQ, this right triangle OQD or ODQ. This angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha, well, because 90 degrees minus alpha plus alpha is 90 degrees. As 90 degrees plus 90 degrees equals to 180 degrees. That is the sum of the angles in a triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. So this angle is equals to 90 degrees minus alpha. We can write here that it equals to beta. Angle AOB, this angle is 90 degrees. Because it is AOB is a quarter circle. So this angle AOB equals to 90 degrees. Therefore 90 degrees minus beta equals to angle AOP. So 90 degrees minus beta equals to the missing angle here. So 90 degrees minus beta. Beta is 90 degrees minus alpha. So we can substitute beta by 90 degrees minus alpha. And we get here that if you open the brackets, you get that 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. So we found out that the missing angle here equals to alpha. In the right triangle OPAPO, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But according to our definition, 90 degrees minus alpha equals to beta. So you can write here that this angle equals to beta. In the right triangle OQD, this right triangle, tangent alpha equals to OQ over QD. I'll write it down. In the right triangle OQD, this right triangle OQD, tangent alpha equals to QO over QD. Repeat again, in the right triangle OQD, tangent alpha equals to QO over QD. So QO equals to x according to our definition, so we substitute QO by x, and QD equals to 12 units according to what we have already found out, so we substitute QD by 12. In conclusion, we found out that according to equation number 1, tangent alpha equals to x over 12. In the next step, we'll focus on the right triangle APO, on this right triangle APO. In the right triangle APO, what is the value of tangent alpha? It's very easy to see that in the right triangle APO, tangent alpha equals to AP over PO. So I write it down. This right triangle APO, tangent alpha equals to AP over PO. Repeat again, in the right triangle APO, tangent alpha equals to AP over PO. AP is 12, so we substitute AP by 12 over PO. What is the value of PO? It is very easy to see that PO equals to PQ plus QO. PO equals to PQ, that is 7, plus QO, that is X. So in total, PO equals to X plus 7. So we substitute PO by X plus 7. Here PO is substituted by X plus 7. So in conclusion, found out that according to equation number 2, tangent alpha equals to 12 over X plus 7. So we have two different equations for tangent alpha. According to equation number 1, tangent alpha equals to X over 12. Well, according to equation number 2, tangent alpha equals to 12 over X plus 7. We create equation number 3. Equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. So tangent alpha according to equation number 1 is x over 12, and it must be equal to tangent alpha according to equation number 2, that is equal to 12 over x plus 7. In conclusion, we found out that according to equation number 3, x over 12 equals to 12 over x plus 7. We'll cross multiply this equation and we get that according to equation number 3, x times x plus 7 equals to 12 squared, that is 144. We'll open the brackets on this side of the equation and we get that x times x is x squared, x times 7 is 7x, and equals to 144. We'll subtract 144 from this equation and we get the quadratic equation that states that x squared plus 7x minus 144 equals to 0. So this is the quadratic equation. In this quadratic equation, a equals to 1, b equals to 7, and c equals to minus 144. Actually, those are the coefficients of the quadratic equation, and the general quadratic equation is ax squared plus bx plus c equals to 0. A is 1, b is 7, and c is minus 144. And the general solution for any quadratic equation is x, we are looking for the value of x, of course, equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Here, a, b, and c are the coefficients of the quadratic equation. I repeat again that the general formula for any quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So, I repeat again that a in our quadratic equation equals to 1, b equals to 7, and c equals to minus 144. So we put the data inside this equation and we get that x equals to minus b. B is 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, and c is minus 144 over 2a. 2a is 1, so 2a is 2 times 1, that is 2. So x equals to minus 7 plus minus square root of, actually, minus 4 times minus 144 is equals to 576 plus 49 is 625 over 2. So x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is equals to minus 16. So we found out that x equals to minus 16. But because of the fact that x is the length of this line segment OQ, it is a length, so a length must be a positive number. Again, x is the length of line segment. It must be a positive number. Therefore, x cannot be equal to minus 16. We cancel this solution, that is a negative number. And we're left only with the second solution, that x equals to minus 7 plus 25 over 2. Minus 7 plus 25 is 18, and 18 over 2 is 9. So finally found out that x equals to 9. This 9 segment x equals to 9 units. So, and what is the area of quadrilateral AODC? The area, we divide the area of quadrilateral AODC into 3 parts. The first part is the area of the right triangle APO. We define it as A1. The second part is the area of the right triangle OQD. This right triangle, we define this area as A2. And finally, the third part of the area of quadrilateral AODC is the rectangle CDQP. We define this area as A3. And of course that A1 plus A2 plus A3 in total will be equal to the area of quadrilateral AODC. So we calculate each area. So the area of this right triangle APO it is A1. So complete the right triangle APO. Side AB equals to 12 units, and side PO equals to 7 plus x, and x equals to 9. So in total, PO equals to 7 plus 9, that is 16. So A1 is the area of this right triangle APO, and the area of any triangle equals to the base, that is AP, times the height to the base, that is PO, over 2. AP is 12, the height PO is 16, divided by 2. 16 over 2 is 8, so we have 8 times 12, that is 96. So we found out that A1 equals to 96 square units. Okay. In the next step, we find out the area of the right triangle OQD. So we copy the right triangle, a new page, and we find out the area of this right triangle. QO equals to x, and x equals to 9. QD equals to 12. So this is, so actually A2 is the area of this right triangle OQD. The area equals to the base, that is QO, times the height to the base, that is QD, over 2. QO equals to 9. The height QD equals to 12 over 2. 12 over 2 is 6, and 6 times 9 is 54. So we found out in conclusion that A2 equals to 54 square units. And finally, we found out the area of this rectangle QPCD. The area of rectangle QPCD equals to the the width times the length. So it is 7 times 12. There rectangle QPCD equals to PC times DC. PC times DC PC is 12 and DC is 7. So there equals to 12 times 7, that is 84. So if I note that A3 equals to 84 square units, and the area of quadrilateral ACOD this is the sign for the area, the square brackets, equals to A1 plus A2 plus A3. A1 equals to 96 square units, A2 equals to 54 square units, and finally A3 equals to 84 square units. 96 plus 54 is 150, and 150 plus 84, it is 234. So we found out that the area of quadrilateral ACOD it is equal to 234 square units. Repeat again, the area from this quadrilateral AODC it is equal to 234 square units. So in the next step, I'll summarize the lecture. So in this lecture, we found out the area of quadrilateral AODC. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have side ACD is equal to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Our mission is to find out the area of quadrilateral AODC. Okay, so first of all, we did construction from point O. We go perpendicular on AC, on chord AC. Point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay, and this angle AOB equals to 90 degrees because AOB is a quarter circle. So from the center of the circle that we can create by completing the quarter circle to a circle, that is to say from point O, we go perpendicular on chord AC. Okay, and here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. So if we have a perpendicular from the center of the circle, that is to say from point O, that bisects the chord, like in this drawing, chord M from the center of this circle, that is to say from point O, bisects chord AB, that is to say AM equals to MB. Therefore, whenever the perpendicular from the center, and whenever we draw from the center of the circle a perpendicular to a chord, the perpendicular also will bisect the chord. In this case, we know that OM is perpendicular to AB, Therefore, OM will bisect chord AB. That is to say, in this case, AM will be equal to MB. So we can actually implement rule number 11 in our drawing. Why? Because again, point O is the center of the circle that we can create by completing the quarter circle to a circle. From the center of the circle, we draw perpendicular OP on chord AC. According to rule number 11, the perpendicular OP on AC will also bisect chord AC. That is to say, AP equals to PC. But AC in total equals to 24. Therefore, OS will bisect 24 into two halves. So each half will be equal to 24 over 2. AP equals to 24 over 2. And PC equals to 24 over 2. That is, of course, 12. So each half equals to 12 units. AP equals to 12 units and PC also equals to 12 units. This is according to rule number 11. Okay, in the next step, we did another construction from point D. We draw perpendicular on PO. Again, from point D, we draw perpendicular on PO. That is to say, this angle equals to 90 degrees, and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. So actually, if we focus on quadrilateral PCDO, inside this quadrilateral we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here, angle CDQ, must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. Therefore, inside quadrilateral PCDQ, we have four right angles, and any quadrilateral that has 4 right angles must be this right angle if not a square. So we relate to quadrilateral QPCD is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That is to say, DC equals to PQ. And DC is 7, therefore PQ must be also equal to 7. Likewise, in rectangle PCDQ, PC must be equal to the opposite side QD. But PC is 12, therefore QD must be also equal to 12. In the next step, we defined line segment QO, this line segment as X. And then we define this angle ODQ as alpha. So inside the right triangle OQD, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha, because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. This is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha, and we defined 90 degrees minus alpha as beta. So we can write here that this angle equals to beta. We know that angle AOB equals to 90 degrees in total, and this angle equals to beta. Therefore, the missing angle must be equal to 90 degrees minus beta. This is the missing angle, angle AOP. This is the missing angle. The missing angle AOP must be equal to 90 degrees minus beta. So what is the value of 90 degrees minus beta? 90 degrees minus beta equals to 90 degrees minus beta, and beta is 90 degrees minus alpha, so we can substitute beta by 90 degrees minus alpha. So here we open the brackets and we have 90 degrees minus 90 degrees is 0, and minus times minus is plus, so in total this expression equals to alpha. So we found out that the missing angle here, angle AOP equals to alpha. So in the right triangle AOP, this angle equals to alpha. This angle equals to 90 degrees, therefore this angle must be equal to 90 degrees minus alpha, of course. But 90 degrees minus alpha is beta, so we can substitute 90 degrees minus alpha here by beta. Then we focus on the right triangle QOD. In the right triangle in the right triangle QOD, tangent alpha equals to QO over QD. I repeat again, in the right triangle QOD, tangent alpha equals to QO minus QO over QD. According to our definition, QO is x, so we can substitute QO by x over QD. QD is 12, so substitute QD by 12. So in conclusion, found out that according to equation number 1, in the right triangle OQD, tangent alpha equals to x over 12. Then we focus on right triangle APS or APO. This right triangle APO. This angle equals to 90 degrees, therefore this is the right triangle. In this right triangle APO, tangent alpha equals to AP over PO. Repeat again. In the right triangle APO, tangent alpha equals to AP over PO. AP is 12, so we substitute AP by 12. And what is the value of PO? From the moment it's very easy to see that PO equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is x. So in total, PO equals to x plus 7. Therefore, we substitute PO by x plus 7. So in total, we found out that in the right triangle APO, according to equation number 2, tangent alpha equals to 12 over x plus 7. So according to equation number 2, tangent alpha equals to 12 plus x plus 7. While according to equation number 1, tangent alpha also equals to x over 12. Therefore, we created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 equals to x over 12, and it must be equal to tangent alpha according to equation number 2 that is equal to 12 over x plus 7. Here we cross multiply this equation and found out that x times 7 equals to 12 times 12, that is 144. Here we open the brackets on this side of the equation and found out that x squared plus 7x equals to 144. Here we subtracted 144 from this equation and finally we got the quadratic equation that x squared equals x squared plus 7x, x squared plus 7x minus 144 equals to 0. In any quadratic equation, and the general formula for any quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So here, in our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. And the general formula for a solution of any quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. I remind you that a, b, and c are the coefficients of the quadratic equation. In our specific quadratic equation, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So we can put the data inside this formula in order to find out the value of x. That is the value that we are looking for. This is x equals to QO. So x equals to minus b. B is 7, therefore minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, that is both. So b squared is 7 squared, that is 49, minus 4 times ac. Minus 4 times a is 1, and c is minus 144. So it is minus 4 times 1, that is 4, times minus c, that is minus 144. Minus 4 times minus 144, it is actually 576, plus 49, in total it is equals to 625. So x equals to minus 7 plus minus the square root of 625 over 2. The square root of 625 is 25. So in conclusion, we found out that x equals to minus 7 plus minus 25 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So the first solution is that x equals to minus 16, but because of the fact that x is the length and the length must be a positive number, we cancel this solution and we left only with the second solution, that it's possible that x equals to minus 7 plus 25 over 2. Minus 7 plus 25 is 18 and 18 over 2 is 9. So we found out finally that x, that is to say line segment QO that is equal to x, it is equal to 9 units. Now we can find out the area of this quadrangle ACDO. We divided the area of quadrangle ACDO into 3 parts. The first part is A1, that is the area of the right triangle APO. The second part is the area of the right triangle A2, that is the area of the right triangle QOD. And finally, the third part of the area of quadrangle ACDO will be this rectangle, that is PQDC. Okay, so what is the area A1? A1 is the area of the right triangle APO. So I copied the right triangle here. This is the right triangle APO that I copied from the original drawing. AP equals to 12, PO equals to 16. Yeah. PO is PQ plus QO. Again, PO is PQ plus QO. PQ is 7 and QO is X, that is 9. So in total, PO equals to 7 plus 9, that is 16. So PO is 16. Therefore, the area of the right triangle PO equals to the base, that is AP, times the height to the base, that is PO, over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total the area equals to 8 times 12, that is 96. So I found out the A1 equals to 96 square units. Then we found out the area of A2, that is the area of the right triangle QOD. Yeah. So I copied the right triangle QOD. Here, this is the right triangle QOD. They call it from the original drawing. OQ is X, that is equals to 9, and QD equals to 12 units. So the area of the right triangle QOD equals to the base QO times the height to the base QD over 2. QO times QD over 2. QO is 9, QD is 12 over 2. 12 over 2 is 6, so in total this expression equals to 9 times 6, that is 54. So I found out that the area A2 of the right triangle QOD equals to 54 square units. And finally found out the area of A3, that is the area of rectangle PQDC. The area of rectangle PQDC equals to the width of the triangle times the length of the triangle. And the area of rectangle QPC equals to the width of the triangle times the length of the triangle. The length is, this is 12, and the width with DC is 7, and the length is PC, that is 12. 12 times 7 is 84. So A3 equals to 84 square units. In total, the area of this quadrangle AODC equals to A1 plus A2 plus A3. The area of quadrangle that we are looking for, quadrangle ACDO, equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. So in total, 96 plus 54 plus 84 equals to 234 square units. We found out finally that the area of this quadrangle AOCD equals to 234 square units. Okay, thank you very much.